I started my journey into Dash about 6 months ago. And so part of that, I started looking into instant send. So it was one of the differentiators for Dash, and I wanted to know how it worked. So I started looking into instant send, and so I put this presentation together, and I actually have one budget proposal under my belt as well. So I hope a lot of people here, or people that watch this, are Bitcoiners that are new to Dash specifically. So we're going to start at very high level. So bear with me, but then we're going to dive deep into the details of exactly how it works and why it's a secure mechanism, and it brings a lot of value to the Dash protocol. So it's on by default in most wallets, and it's as fast as 1, 2, 3, and we have money. Now, a lot of people who have been in the blockchain space with Bitcoin have seen this screen on a Bitcoin wallet. However, this is much different because in Bitcoin, this would be considered a zero confirmation transaction. And when the blocks weren't full, merchants could successfully accept these for low amounts. Now, with Dash, what this is doing is it is generating a level of confidence for the merchant to receive this transaction at much higher amounts and instantly have a level of confidence of several blocks of confirmation. So, and that's, I mean, that's the magic. You've talked, you know, when I learned about this, I was very interested in knowing how is it actually doing that under the covers. Because you know, I hate to just read something and believe it without really diving in and understanding it for myself. So before we get into that, there are some restrictions around instant send. So just to be as a thorough presentation here. So your inputs that you're spending for an instant send transaction, it must have, all the inputs must be confirmed in at least 6 blocks. So that means if I instant send money to someone, they cannot just instant send to someone else. They're going to have to wait a little bit before being able to spend those instantly. There's a minimum fee and some other limits here, maximum of 1,000 Dash, which is a substantial amount today. Yeah, so when I first started looking at Dash, it was around the $10 range. I was like, I don't know. Then $30, like, okay, I'm in this thing. So 1,000 Dash has gone up a lot since then. So for people, there's been a lot of fork talk lately. So some people may be familiar with user-activated soft fork. So what's essentially happening under the covers is we are generating a consensus to basically, if a block tries to double spin that instant send transaction, all the nodes in the network in that 2-second time frame have generated consensus to, if a block comes that conflicts, all the nodes are basically going to user-activated soft fork that block off the network. So that may be helpful to some people that are familiar with that term. I guess the other way is just all the nodes in the network are going to communicate, and if a block tries to double spend, all the nodes reject that transaction. So the miners are not going to create these blocks because they're not going to get paid from them. So real quick, I know we have a lot of people that know about master nodes, but in Dash, master nodes are kind of one of our differentiators. It allows us to have this other network of nodes that are compensated so we can make their services more expensive, don't have to worry about how much it costs to run a node, so that helps with scaling. In order to run a master node, you need 1,000 Dash. So this kind of creates inside of Dash a proof-of-stake system. And we're leveraging this master node network, this proof-of-stake system, to generate these consensus that we need to generate that consensus to do the user-activated soft fork and blocks that may try to double spend that transaction. Now, master nodes do a lot of things. We are just going to mainly talk about the instant send piece of it. But there's about 4,000 master nodes today spread around the world. And yeah, I think we're right. You'll probably hear more about the other stuff. I believe budget proposal is one of the really cool things, but there's another talk In a little bit, that'll touch on that. So now we're going to dive a little deeper. And basically, on the network, it looks pretty much just like a Bitcoin transaction. We are changing one little bit in the transaction to identify this as an instant send transaction. Now, for each one of the inputs in this transaction, a unique score is calculated for every master node. So you have the 4,000 master nodes, and a score for that input is created for each master node. Then we're going to sort the list of master nodes, and the top 10 are going to be the quorum, or the ones that are responsible for voting whether or not to lock in that transaction. So since we select the top 10, we need 6 votes to confirm the instant send. And after any node on the network receives those 6 votes, they can be assured that that input is now locked, and any conflicting block from a miner will be orphaned from the network. So if you have an input to a transaction or have lots of inputs, you could be potentially hundreds of master nodes could be involved in this voting process. So it's extremely distributed across the world, across the network. So this is, for those that can't see, hopefully these will be put online, but this is kind of an example of what's happening. So in this transaction, we have 2 inputs to our transaction. And then we have our master nodes, 1 through 4,000. And we're taking the input, and we're going to hash that with the master node's unique identifier and come up with that score. And so that gives us a score for each master node, which we can then sort the list of master nodes. So this is now sorted. So we have a different set of 10 master nodes for each input in this one transaction. Then 1 second later, we get our first incoming set of votes. And we got 4 from here, 3 on this one. So we're still in a limbo state. And then 1 more second later, we get more votes. And once we get more than the 6 votes, that confirmation is considered secure and locked in. Yeah. So now we're going to dive even deeper. So how do we calculate this score? We are actually, I kind of simplified it a little bit, but each input, 4 blocks later, that is actually the block hash that's used for calculating the score. So that's one of the reasons we need to wait 6 blocks for an input to be used for instant send, is because we need to look kind of in the future. So that's a safety mechanism. The second hash is the master node VIN, which is a unique identifier. When the master node is created, the transaction 1000 dash is required in a transaction that creates that master node. And the resulting hash of that transaction that creates the master node is that VIN, or the master node unique identifier. So, and then we concatenate those 2 items together and take another hash. The more hashes, the better, right? So then we gives their score and we sort the list. So that's how it used to be. So if instant send actually on the network is currently disabled because there's a weakness in how this score is calculated. So instant send actually had the power to roll back up to 24 blocks. So let's say a node received the solid transaction, and it was confirmed in 4 more blocks after that. Then they received votes for a conflicting transaction that would basically double spend that same money somewhere else. Instant send, the nodes would actually roll back those 4 blocks in preference of the instant send transaction. So that's a very powerful mechanism. It's one of the reasons that people were very confident in the acceptance of instant send. However, it's one challenge is that master nodes can be confirmed in 15 blocks. So there was a way to compute your VIN offline to, if you had 6 masternodes just by yourself, you could actually compute your VIN and you pre-compute your scores ahead of time and win for a particular instant send. So if we have, this is your input transaction. This is just, we're just talking about one transaction, or one input for this, just to keep it simple. So +4, that, this is the block hash that was used for that input. So after, at this point, we can calculate, we can create a bunch of masternode creation transactions all offline. We can do thousands, millions of them in a short period of time. So that, and then we can calculate the score if we were to instant send this input. Because then we can do all that offline because we have all the information we needed. We have input I+4 plus our VIN. So that would allow us to register 6 new masternodes. So that would cost, you would have to have, about $2 million and malicious intent to be able to pull this off. And then after your masternodes have been confirmed, so 15 blocks later, you can then spin this input. And let's say you send the money to an exchange. Then 1 block later, after the standard transaction, not instant send here, you can then send an instant send transaction plus the 6 votes from the masternode that you've just created. So this was a very serious weakness, and it I would say there's double spend is very bad. We want to block all that, but there are some other edge cases around the scenario of one individual having more than 6 masternodes. So those were, there's some like to-dos in the code saying this scenario we should probably do this better, but it hadn't been fully implemented. So there's some fork type things that would potentially be possible. That being said, instant send has been disabled. So there is what we call sporks, and that allows certain features to be turned off. Typically, it's used when we upgrade the code and change the blockchain rules to do hard forks and safely roll in new changes. It allows the core developers to do that process safely. It's very similar to, Bitcoin has an emergency messaging system where the core development team holds those keys, similar to that. So the work on fixing this is in progress. It's in 12.2. And so I'll say disclaimer, these are still being developed and tested and subject to change. But what they're looking at doing so far is changing instant send so that it doesn't roll back blocks anymore. So we're just going to basically say from this point forward, no blocks can come to these nodes that conflict or double spin that transaction. And then the key change here is calculate score now includes if we go back here, calculate score used to depend on this block hash and this offline VIN. Now it's going to include this I+4, this block hash, plus this guy here, A+15. So they can no longer create these masternodes offline and pre-calculate that score ahead of time. They actually have to create the masternode, wait 15 blocks before they can calculate the score. I said there are some edge cases around if someone, single person controlled a quorum of the masternodes. Those edge cases have been filled out much better to reduce the risk there. So it's kind of a belt and suspenders type approach. It's been fixed in almost 3 different ways. That being said, instant send still provides greater than, more than 1 block confirmation, maybe several blocks. So it's whatever confidence, user activated soft fork brings to accepting a transaction. So this is, a huge win for Dash in that we can still provide this functionality. And I'd say that, what I think is security is always a progress. You get more and more secure. But the core team was extremely responsive and took the appropriate steps to close this as quickly as possible when it was brought to their attention. So yeah, I think that's it. So any questions? I went pretty fast. This guy right here. He asked if instant send will be possible in other wallets. I mean, so most of the Dash, I looked at a couple, like 3 of them, I believe, Dash, and there's actually 2 Dash iPhone wallets, and both of those do instant send. And I'm not sure on Jack's, but several of the wallets do it by default, and it's really, it's like changing the message header to send it. Sending is extremely easy. If you want to be a wallet and receive the, pop-up say, we received an instant send, that takes a little more code in order to do, but definitely we'll see that go. Yeah. He asked about does the sporks in the code make it Dash more centralized or risk because developers can shut down features? I did the corollary to Bitcoin as they have a messaging system, but typically the sporks are only used as security and security concerns, or when they're doing the blockchain upgrades or rolling in a new feature. So I guess it's do you trust the core development team? I'd say if any point the core development team is in question, the budget system allows the Dash network to fund a different development team. So I think from a development point of view, I think that allows a lot of safety. And this, we had a security concern, and they were able to shut off a particular feature for the good of the network. And if they were to abuse that, I think it would be quickly remediated in terms of the budgeting. Yep. I don't know a full list of the sporks, or what's possible with those. I believe it's just turning off mostly the additional features that Dash brings. So I would say that, I mean, if I guess I'll repeat the question was, the governments were able to kind of coerce the developers to get the keys and start using them to shut things off. I mean, the other side of the key is in the nodes. So if the government is in control of the keys, people upgrade their nodes to a new key that they don't control. We've
got time for one more.
Okay, one more. Yeah. There's lots of ways to fix the problem. The core developers, they were already refactoring quite a few things with some of the calculate score rank, so that's what and again, it's still in flux, so they may add something like that as well. All right, I think that's it. Thank you very much.